Number 3 on the 4C worksheet packet. I've drawn the situation. We've got a street with a 38-degree angle, the horizontal, which is absolutely mind-numbingly insane. You get for your information, on highways and roads, you typically get a steep grade sign if you have a 6-degree slope. 6% grade will get you a slope sign. So, okay. All right. We've got the mass of the box. We've got the coefficient of static friction. We've got the force applied. Everything else we can figure out. And what we're looking for, what we would like to know, is the force of static friction. Okay. So we have this force applied. We also, remember, have force of gravity on the y and force of gravity on the x. On these problems, I find it really useful to move the force of gravity on the x up. Because remember, you can move any vector as long as you move it perpendicular to itself. So what I do is I transpose this f of gx to up here. That helps me mentally. It helps me visually see that, oh yeah, okay, that's opposing the force of static friction. That's what the force of static friction is opposing. So that's a little trick that I play. I usually still leave it down here for calculation purposes, but I'll make some sort of note to myself that, oh yeah, that's what that is. Okay, so always start with what?
The applied force and the g of y can go like on top of each other?
For image purposes, yes. In reality, if we were doing a full-on free body diagram, the way we would show that would be we would do 2 different colors. And we'd do that. And they add up to one vector, but
So since you're adding up
yeah.
You add them together in the end.
Yes, you do add them together in the end.
Yeah, you do this, right?
Okay, so we start with get some. Sum of forces. Okay. Sum of forces on the y. Is this package rising up off the surface or sinking down into the street? No. So sum of forces on the y equals 0. This is all of our forces up minus all of our forces down. Name me a force up.
Force normal.
Normal force. Name me a force down.
Force applied.
Force of gravity on the y. And force applied. So we have 3 forces on the y-axis. Beautiful. Okay, we now have an expression for normal force, yeah? Wunderbar. Let's look at the x-axis, shall we? Okay. Forces, you know, I don't know, left, right, doesn't make any sense to me. Uphill, downhill. So, force uphill minus force downhill. Is this package sliding? No, we're told it's being held in place. So, 0. Okay, what's our force uphill? F sub s. What's our force downhill? Yep. Force of gravity on the x. And these are equal to 0. Therefore, they're equal. So I'm actually just going to do that. Okay. So at this point, do you have enough information to solve for f of s? Because remember, You have an expression for each of those things. Everything in that expression, you know. Are there other questions on that one? You all know how to find this angle. Yeah, it's equal to the slope of the hill. Other questions? Is that enough of a hint to get you up over the crest of the hill on this one? Okay, so let's go on to 5. No?
You gotta wait till we finish.
Can we, like, finish it and then-
Caleb finishes.
Okay, that's fine. Let me stop the video and erase it, and I'll start moving on to 5.
The racing part's the part I don't like.
I'm still going to stop the video.